Okay. Good morning and welcome to the February 2016 Saskatoon Testing Discussion Group. Today we're going to depart from our usual process of me standing at the front talking and developing a mind map, and we have a guest presentation this week. We've got Ben Stoltz from Vecima Systems, and he's going to come talk to us today about testing when there's hardware as part of your software problem. Well, it's your software solution. Software is never the problem, right? It's always the solution. Mm-hmm. So take it away, Ben.
Okay, great. Thanks, Jason. So today I wanted to talk to you a little bit about testing hardware, and there are a couple of areas that I wanted to touch on, and one of the big ones is identifying what testing hardware is, identifying some of the challenges that Vecima has, identifying what's out there for testers. So as a contributor to this group, as a member of this group, I've found a lot of times that there isn't really much out there for testers. So I talked to that a little bit, and then finally I answer the question if there is hope or not for hardware testers. So no spoilers. But to get started, my name is Ben Stoltz and I'm a tester. I work at Vecima Networks. I'm the manager of the verification and validation group. So verification makes sure our products does what it's supposed to do. Validation makes sure that it does what it's supposed to do at a customer site. I've worked in test-related roles for the last 13 years, and I've been at Vecima for 11 of them. A lot of my current roles include test leadership and management of large test teams, both here in Saskatoon and remote. We have a team in India. We have a smaller team in Burnaby. My primary role is to help the groups at Vecima design test cases and help them execute those test cases and hopefully get everything done on time. We do a lot of customer interop and validation. Some of them call acceptance, test plans, things like that. And it's not just hardware testing at Vecima either. We design our own hardware. We make sure that hardware works, but that hardware is really viewed upon as a platform for software to run on. So just to make sure that everybody understands, Vecima makes all of their own gear. This is an example, and I'll get into it a little bit more. But when I say hardware testing, I'm not talking about testing if your mobile site works on 19 different Android phones. It's actually testing to make sure that the RC networks on this device do what they're supposed to be doing. So I like testing. I like finding problems, and more so I like finding the cause of the problems. I like being the hero, riding in on my horse to identify where the problem is, hopefully help the developers get there sooner. I like identifying misinterpretations and misunderstandings. So as someone who interacts a lot with our customers, it's pretty easy for me to see what's going on between what the customer is seeing and what the developer thinks they're saying. I like using my superpowers. I call them superpowers: intuition, observation, and asking questions. And I think any tester should consider those your superpowers. I like leading the test group. I like motivating people to test. We've got over 20 people in our test group now. I don't know the exact number. But not a lot of them are testers. A lot of them are developers. A lot of them are electrical engineers. A lot of them have various education backgrounds and work experience. I like helping our testers. I like reading and learning about testing. That's why I'm here. I like following test personalities. Jason's introduced me to a few interesting ones. And those of you that work at Vecima know that there are a few that I like to follow based on the discussions we have. So testing hardware, what is it? Testing hardware is basically like any other form of testing. You want to make sure that what it is you're testing is going to work for your customer. So I've taken a few pictures here of our lab at Vecima. This was a couple of weeks ago. Nothing was turned on, but here we've got some expensive pieces of test equipment, some high-frequency oscilloscopes, a spectrum analyzer, and your standard issue engineer's messy test bench. This is a product that we make with the lid off, and you can see the PCB and all the heat sinks in there. We've got cable cards, power supplies, fans for cooling. We do all of this work ourselves. We design our own heat sinks. And we do all of our testing in that regard as well. So with hardware testing, the risks can be higher. You can't just deploy a new version of code. You can later on once the hardware is proven to be working, but field replacements can be expensive. So For example, you test this piece of hardware, maybe you test 5 of these units off a production run, and you figure out that 5 of those units all had really good components in them, but 95 of the other 100 units have RAM that is substandard, so it doesn't work. And then you got to go out to the customer site, figure out, first of all, that it's a hardware problem, which takes weeks and weeks and weeks, and then replace it, which is really, really expensive. Customers don't like doing that either. So some things that I'm used to seeing, QAM analysis tools, digital video and digital data is what Vecima Networks deals in. And QAM channels are things that I really care about. I care about constellations of QAM channels that look like that and not like that have phase noise in them. We have a whole bunch of pieces of test equipment. This is just an example of one. There's another piece of test equipment that we have. And we've got lots and lots and lots of fiber networks, high-speed video servers, fiber switches, 10 gig switches, 1 gig switches, 100 meg switches, 10 meg hubs. We kind of test with everything. This is a picture. Some of it is from our lab. You can see we've got, I think it's just over 300 cable modems right now, and we have 300 cable modems for testing our existing Ethernet over coax product. We also serve all of our video products with our own head end, and this is a big RF amplification and distribution setup that we have in our server room. And here is just 5 of the 19 racks we have in our server room, containing some of our equipment, some vendor equipment, a bunch of servers, things like that. I won't get into the details other than saying, in addition to hardware testing, we've got to worry about all of the other upstream supporting things that go along with selling to customers like Comcast, Time Warner, Rogers, Shaw, etc. I totally yanked these off our webpage, but these are products that Vecima works on. I've worked on, I think, all of these over the last 11 years, and the one in the top left corner is kind of the one that's making us the most money right now. Our biggest customer is in the US, so our exchange rate, our poor performing dollar, and the exchange rate we get is pretty good. These are all, as you can see, they all have little ears on them and can mount in racks. When you're testing hardware that mounts in racks, you have to make sure that it's exactly this distance, and you have to make sure it can support its own weight. You can't really tell, but the product here is actually quite long, and before we got the ears on it that we have on them now, it would bend quite a bit in racks. So those are examples of some things that you might not think about when you're doing testing, but really affect how a customer sees things. The middle 2 units are WiMAX. The top is a base station, the bottom is a subscriber station. So the subscriber station would basically bolt to the side of your house, and the top piece would be on top of a tower somewhere transmitting wireless RF waves to your house. And those are outdoor units, and I'll talk about that in a minute. And this is our Terrace TC1200 product, and it was originally designed to be an outdoor equipment chassis, but with the bleeding edge parts we were using, we found that we needed active cooling for it. And we've since replaced it with an indoor chassis that's a lot smaller. So some of the pros and cons of hardware testing. Hardware is typically used in a specific application. And what I mean by that is this card slides into a chassis that we make. So we don't have to worry about what some other company makes. We don't have to worry about making sure that it works in the slots in your chassis that you have in your computer at home, nothing like that. So we don't have to deal with that. So that's one of the pros that we have. We also know about all the I/O on the back. We know which lines are voltage lines, which lines are data. We also know from schematic diagrams what all the ins and outs are of all of those data buses. We have a known power supply. We make our own power supply. We make sure that the power supplies are tested. We might buy a power supply off the shelf and put it into our devices. We know the power supplies are tested. So once we've gone through our rigorous testing exercises, it can be pretty stable, which is good because now we've got to test a bunch of software, which can be unstable. Some of the cons are, you kind of have to get it right the first time, although that's not always the case. We celebrate a little bit when we do get it right the first time. We typically do a Rev 1, Rev 2, Rev 3 of different numbers, and we try and make some considerations for not only functionality, but how is production going to crank out 10,000 of these every quarter? So we think about improving our manufacturing facilities' lives and things like that as well. But when you do board spins, those spins can be costly, thousands of dollars. I'm not sure how many layers this PCB is, but one of the recent ones I'm working with is 18 layers. So moving a component around on the top may not be possible because there might be something directly underneath it. I picked this device specifically to show you because it might be hard to see from a long way away, but there are a lot of components here. And lot-to-lot variation is a problem that we have to deal with. So what I mean by that is, this particular IC here, integrated chip, it might work great for years. And then we're building these things for years. And the company that makes this might put out a run of 1,000 of them that don't work as well as these ones do. So troubleshooting those things in the field are a problem that we have. Some of these chip manufacturers also have different revs of the same footprint or different functionality with a slightly different model and number name. And those are, again, things that you want to think about a little bit. Safety considerations, I've listed it as a con only because it's a pain in the backside, but we want to make sure that the hardware isn't going to electrocute somebody who's touching it. We want to make sure it doesn't burn down your house. We want to make sure it doesn't cause your cell phone to not work. And a lot of the test equipment we have, like what I showed you here, some of it can be pretty complicated to use. So what are some typical hardware tests for Vecima? Well, we want to, test processing performance. So the main processor on the board, does it work when the system is fully loaded? We want to test our RF performance. So when you connect this device to an RF cable and you plug it into a TV, does it even work? Can you see lines on the TV? Do you get packet loss? Lots of things like that. Thermal performance, this can operate between 0 and 50 degrees. It operates a lot differently at 0 than it does at 50. We might even be thinking about things like stability at 50 degrees Celsius. If you've got outdoor equipment, it's even worse because your equipment could be in Houston in the summertime and Alaska in the winter. Mechanical performance, I'll do a couple of demonstrations of that in a minute, but our devices need to adhere to certain mechanical requirements that we have. So they've got to be this particular dimension and they have to have this color of LED, and those things are easy to test, but some of the things are quite difficult. And I'll talk about those in a minute. The I/O verification and performance, it's just how it sounds. We want to make sure that the ins and outs perform the way they should. Onboard communication, so between all of these devices, we have I2C, we could have UARTs, we could have SPI, we could have just a direct line, all of those things. We want to make sure that that stuff is working. And all of the sensors on here, I think we have a couple of temperature sensors on here placed strategically so we can get an idea of what the temperature of the board is reporting. And then we can do intelligent things like turn off the power supply. Whoa, this thing's getting way too hot. Let's turn off the power supply, shut the system down. Yeah, people aren't going to get TV, but at least this thing isn't melting in your server room. So what are some of the challenges? I already talked about some of them, but I'll get into a little bit more detail. So when you're testing hardware, you got to be prepared for variations. Different chip lots, board spins, ECOs, engineering change orders. So when we decide to change something, once it's gone into production, what are the challenges there? We might create a low-cost variant, and of this device, we have created a low-cost variant. And I couldn't find a non-working version that I could just walk around with, but I've got a picture of one that I can show you. We've got increased test iteration, time, and cost for all of those things, right? So if we get a new board spin, we got to do all of the tests over again, essentially. If we need to change out a part, we've got to do a good chunk of those tests all over again. Because again, we want to make sure it works before we get to the field. We want to ensure that hardware won't electrocute someone, burn down a house, or cause problems with other hardware. And how we get around that is pretty simple. There are checklists that we do, we've got procedures, and there are certification bodies out there that protect everybody. Testing mechanical requirements, things like, what are our shipping boxes? How do they perform? Can you stack 3 boxes on top of one another without destroying what's inside of it? Can you drop the box off of a 3-meter desk, and does the equipment inside of it still work? We test things like humidity, temperature, altitude. Shock is, it can be construed a few different ways. We physically shock our devices with an electricity gun, simulating ESD. and seeing how well the exposed I/O ports do. We also test things like connecting a device like this to a shock table that gives the hardware a specific G-force of shocking. So if you're throwing it around at 60 Gs, does it fall apart? In most cases, yes, it does fall apart, but those are some pretty high requirements. One time we had a power supply come loose and the inside of the box was just basically sand. There was no longer any printed circuit boards inside of it. Microphonics involve, we could use something like this to hit the chassis and see what happens, and does the system recover or does it continue to have bad data coming out of the I/O ports? And there's lots more that we can get into. So the two pictures on the left here are the board that I brought actually, and I've done a close-up of this chunk here, and you can kind of start to see how many components there are on the board, and after we're done here, feel free to come and have a look. But we've done a low-cost variant where ignore these chips on here because they're transcoder chips, but what we can do is we can just take the transcoder chips off. We added transcoding as a feature. We could take the transcoder chips off, which are all of these black chips here, and this tiny board and this chunk replaces all of this, right? So all of these components here in the RF chain of this board are replaced by these components here. So it's a completely different animal, so to speak. We have to look at all of our test cases and see how those things are affected. Safety certifications, if you look at your phone and turn it around, you'll probably see some of these stamps labeled on it. FCC, CSA, and UL, which I think is Underwriters Laboratories, or something like that. Anyway, we've got to adhere to a bunch of these standards and make sure that our products, where they're being installed, meet those certifications. And essentially, that's just all safety related, right? Is anybody going to get electrocuted if they touch this piece of hardware? At Vecima, we have 6 temperature chambers. They can go, I think, down to minus 40 or 50 degrees Celsius and go up to 90 degrees Celsius. They're all connected to water lines, so we can do humidity. And because we can do humidity and temperature, we can also do altitude. So for every degree you go up with a certain humidity, you raise 1,000 feet or something like that. I don't know the formula off the top of my head, but we do those sorts of tests here. We do operational tests, meaning this thing will be running at 50 degrees Celsius inside of one of these giant ovens, and we see how it works. Are there any alarms? Are there packets being lost? Is the system behaving well? Is the UI sluggish? And then we'll also do non-operational tests. So we'll ramp this down to minus 40 and we'll let it sit there for half an hour and take it up to 90 degrees and let it sit there for half an hour and do that for 7 days. And then at the end of that 7-day test, we plug it in and see if it still works. So the idea there is that as this is being transported to a customer site, it may be up in the belly of a plane being quite cold and then again land in the middle of the desert in Phoenix or something like that where it's 40 degrees Celsius. We do drop tests, package stacking tests, and there are some application-specific tests. So because a lot of our devices live in cable networks, whether it's data or video, we use coax cables. Everybody's probably seen these, although perhaps not so much in your house anymore. But we do things like tests to ensure the retention. So the male part of this cable, when put into this device here, what we do is we just basically take a slack cable and we don't thread it on. And we dump it upside down and put a weight on here and see when does that cable actually fall out. And there's actually a test for that. There's a requirement for that. It seems strange, right? I don't know why you wouldn't thread it on. You just forgot, I suppose, but there's an idea there that if there's a certain retention, then maybe you can get away with some lackluster maintenance. We do tests for external shearing forces. So these 4 ports here, they're all a little bit different, or they're all the same except for this last one, and I put a terminator on it. And what we do for a shearing force is we just basically take a wrench, a torque wrench, and we apply a certain amount of torque to it. And if this connector comes off, we failed that shearing test. So the idea is if one of you were installing these cables on the back of your set-top box or cable modem, and you twist too tightly, hopefully that connector doesn't come off. So we've kind of figured out how tightly someone can twist with their fingers and how tightly someone would need to actually torque on a wrench to get it to break off. And those are things that we think about as well. if you have an outdoor piece of hardware, you've got even more testing to do. Submersion testing, you dunk it in a pool of water essentially. I've heard about demos at trade shows where, you know, Sony has a cell phone sitting in a pool of water accepting calls or playing Netflix or something like that. We do shock and lightning safety. So I was talking about shocking it, and it's in the order of 10,000 plus volts. And we have what's called the salt fog test, and I call it the dreaded salt fog test. And what that is essentially you take your outdoor chassis, it's usually metal, and you expose it to salt fog for 7 days. And when you take it back out, it really doesn't look like the way it looked when you put it in there. It really destroys metal. And the whole idea there is it's simulating maybe a salty environment, like on the coasts, and versus here in Saskatchewan where it's really not a problem at all. Other customer-specific challenges that we have, we've got to work within proprietary environments. So we don't make everything that's out there for a cable head end or a data head end. We have to work with all of those devices upstream. And not only do we have to work with that one device that this one customer is using, but there might be a different device made by another vendor that another customer is using. We have to ship our products to all areas of the world. So instead of 120 volts AC, we've got, across the pond in Europe, we've got a completely different setup there. And specifically in Europe, the television channels and audio formats are all different, really, based on what country you're in. So if you're in Germany, the video format is different than where you're in France, which is different from where you are in Spain. And a lot of those things we have to think about. They also have different safety requirements too. We have to warn customers about tornadoes, floods, blizzards, things like that. So you can imagine if our devices didn't tell somebody a tornado was impending, that would be a pretty big problem for us. And obviously the people that are facing the tornado. And then we also have pressures of stability. So people don't like it when their TVs stop working during Super Bowls, Survivor finales, and elections. Our products need to remain running in those cases. So when I started really getting into testing, I was probably a tester for 4 or 5 years, just kind of starting to get my footing. I had graduated and landed a testing job shortly out of school. And like I say, about 4 or 5 years in, I started appreciating testing and the craft of testing. And, these discussion groups are great and they foster that. But what I found was that a lot of my peers were software testers. A lot of the people I like to follow are software testers. So I mentioned I liked learning and reading about testing. So as a hardware tester, I kind of always felt like I was alone. And I like following testing personalities. And again, a lot of them are software based. So some popular test topics: software testing, rapid software testing, test-driven development. I don't remember what's that? Acceptance test-driven development? Is that what it is? Okay, good. You can see I've read a lot about that. Behavior-driven development, using things like Cucumber, Robot Framework, etc. And great ideas that you read about. I think The Verge did an article on how Netflix tests their setup, and basically they created their own thing they call Simian Army that just destroys their network, and that's how they develop, and that's what their production environment looks like. Docker is some really cool stuff. Vagrant, I think, is one of the most interesting things from a developer perspective. And infrastructure as a service, being more of a hardware guy, I really like how you can use Git to do your change management. So your switch configurations, your server configurations, all of that stuff lives in a code repo. But none of that's hardware testing. So I like following test personalities. Michael Bolton, James Bach is my favorite, Nancy Callan, Michael Larson, Lee Copeland, Kem Kainer. None of them are hardware testers. So is there any hope? Well, there isn't much out there for hardware testers. There are no topics, blogs, or personalities, unless you think I'm a personality. Hardware testing and sites and blogs, they really talk about specific applications. So, hey, I got this Raspberry Pi, and I'm doing this weird thing that nobody would ever imagine doing with a Raspberry Pi. I'm automating my house with this off-the-shelf piece of equipment. Nest is a big company that's doing hardware that you have all probably heard of, but it's specific application. It doesn't really help me. And I found that most of the hardware testing skills are obtained through mentoring, So when I started at Vecima, there were a bunch of people there that knew their stuff, and I learned from them. A bunch of learning on my own, like what the heck is that thing anyway? I need to understand it. I may not care about it, but all of the components on here, I don't need to know exactly what they do, but I need to get an idea of what they do. Vendor equipment. We buy a lot of test equipment from our vendors, and they make it complicated, and therefore they give us free training or make us pay for training depending on the vendor. So we learn a lot from there. There's a lot of theoretical knowledge I obtained through school and through self-study and whatnot, but observation was the biggest thing. So then when I started thinking about that, isn't that all true for software testers or testers in general? We get mentored, we observe things, we've got lots of vendor equipment. It may not be a piece of test equipment, it might be a piece of test software. It may be App Engine, it may be VMware, it could be anything. You need to know about those things. You need to learn, what the heck is VMware? I don't know, what the heck is Vagrant? I don't know, it's really useful when you start learning about it. So in general, hardware testers share a lot of common skills with software testers. So we make observations, we learn, we have discipline, social and communication aspect. We like to talk to people to find out how something works or to get their advice on how we should test something. And tenacity is a big thing for me. I think that some of my peers at Vecima that I look up to are very tenacious people. And I think that was one of the skills that we talked about when we had one of these discussions about what makes a good tester, and tenacity was on that list. Test equipment is complicated and expensive, so it's very, very expensive. We just bought a really expensive piece of hardware. You can ask me after how much it was. But software can be expensive too. As you start using up compute engines, your bill starts going up. As you start buying software for your team of 100, and that software package could be $500, well, you've got a pretty big bill right there. And you need smart people who are able to make informed decisions. So I like to think that all of us here are smart people that like to think about what we're working about and not just follow a script blindly. And in the end, we've got bugs too. So if we buy an ASIC, like an integrated circuit, just because it's an integrated circuit from a well-established company doesn't mean that it doesn't have its own bugs, right? So Google App Engine probably has its own bugs. MySQL has its own bugs. House-built software has its own bugs. So we all have our bugs. So these are things that I find in common, and they're a way for me to relate to some of you who only test APIs. And I shouldn't say only, but as a hardware tester, I didn't mean that. So common testing methodologies and tools. Well, black box and white box testing. Exploratory testing isn't on here. Heuristics. We inject failures. So when you're injecting failures into a database, you can just type some code in. When we're injecting failures, we shock it with electricity, or we try and break it and see where it breaks. There's blocking out large sections of functionality. I'm going to really fly back here and discuss what I mean there. But so like this whole block does a specific thing. So now we only really have 4 things that we care about instead of thousands. So, like you would block out a software architecture diagram, you can block out your hardware as well. We do functional testing, just like software testers do. We do requirement-based testing, just like software testers do. And there are many more common testing methodologies and tools. So as a hardware tester looking forward, a lot of hardware is being built as a platform, meaning that the hardware really doesn't matter anymore, and the software is where the features are being added. So things like software-defined networking, I don't know if anybody's heard about that, but you can use software to greatly affect how your switch works. So instead of going to Cisco and buying 10 different pieces of switching gear, you could potentially have that one piece of switching gear and one piece of hardware running different software layers that you've paid for. You can do a lot more configuration as well. So as testers, regardless of being hardware or software testers, we have to adapt. And I think that is the biggest common ground here that we all have. We need to learn about new technologies. So that's kind of kept me going. And I was trying to find a quote, so I made my own. I didn't really like it so much. And then on Sunday when I was finishing this up, a software tester sent out a tweet, and it was literally the last tweet on my list that I hadn't read. So Michael Bolton is a software tester. And he says, we test to discover things, especially problems that would be ruinous or damaging to our clients, our customers, and our societies. And what a better way to end this presentation than to talk about that being the common ground between software testers and hardware testers that may not have found their place in the community. And that's it. Any questions?
Excellent. Does anyone have any questions for Ben?
So you've got the machines to simulate different humidity levels and temperature, and you use that to basically simulate altitude. Is pressure of the atmosphere not is that negligible compared to those other two factors, or just too expensive to test?
Well, we don't generally test atmospheric pressure, and we found that that's not typically a requirement that our customers are looking for. If our customers were looking for that, we would certainly be testing atmospheric pressure. So no, it's not something we look at.
This is probably a not related question, but I just want to know, so most of the hardware testing, basically physical testing, so it's not like our own QA group, there are other teams as well, like FPGA and other teams in our company, they do this testing?
So what's the question?
Yeah, so are there other teams apart from our QA group that do most of the other physical testing?
Yes. So, a lot of developers need to do their own testing. At Vecima, we've got FPGA developers. They do a lot of their own testing.
And manufacturing?
Manufacturing does their own testing.
Okay.
But we've got a small group at Vecima that does our certification in mechanical testing that's outside of the verification group.
Yeah.
And the reason there is that, you've got to wade through a whole bunch of specs, and once you've done it once, you're the expert. And, those skills are pretty common to all of our hardware.
Any other questions for Ben? Oh, Kirby's got one.
So, I talk into the.
No, there's a dot. There you go.
Ah. It's hilarious.
You guys should make it obvious.
Well, I guess it kind of is.
Yeah.
So I'm curious, when you're testing for a prototype or something like that, how many do you go through as you're destroying them before you say, okay, it's good?
That's a good question. So when we bring up a piece of hardware, we design it in a schematic fashion, and we look at all the connections between all the chips, and we do design reviews on that. Then we do the PCB schematics, and we do a bunch of design reviews on that, and then we actually order the thing, right? And we might be constrained when we do that order by how many chips we can get in a small supply. So we may be only to get 10 or 15. So then we get those in, and we usually try and order much less than 10, so maybe 5. And the reason we do that is, well, you order 5, you plug it into power, and they all smoke. So obviously we have some changes to make. The next rev, that's fixed, but maybe the connection between this chip and this chip isn't working. So we've got some adjustments to make. So during bring up, it's kind of a mix. Sometimes it works really well. Sometimes we can go through 10, 15, 20 units. And we do other things to destroy it too, like doing wire mods. We might pull this capacitor off and solder a shim in between it so it just bridges the capacitor. As far as doing destructive tests, it's usually in the order of 10 to 15 units in total that we destroy. A lot of units we can break and re-break them later on. So I mentioned microphonics, where you hit something with a hammer, it's dented, and we're obviously not going to sell that to a customer, but you can just continue hitting it, and that test is still valid. But there are tests that we do to break things because we want to see how far it can go before it can be broken. But I think 10, 15, 20, I'd be surprised if it was 20, probably more like 10 devices we would break. But this device plugs into a chassis that has many other devices in it, right? So there's a processor module, there's an auxiliary module, there's power supplies. So we need to do a lot of that testing on all of those modules. So it could be 10 of these boards plus 10 of the chassis plus 10 of the other boards to go in. Does that answer your question?
Yeah, well, I was just thinking that that's one of the differences when you're thinking about the testing, is you're actually potentially physically destroying things, whereas in software testing you're destroying virtual things.
Right, yeah.
Usually you can rebuild it fairly easily, but
Yeah.
with those,
Yep.
you're actually having to order and get them done, and we destroy it and like, oh, okay, that one's done. And,
Yeah, there's a technique that we use called I think it's called FEMA, FEMA, failure and I forget what the E stands for. Failure something mode analysis. So you can actually look at the hardware and say like, okay, if this were to happen on the input, what are some things that could happen down here? So you can kind of hypothesize where your failures might be without actually, destroying 100 units to make sure that your theories are correct.
What type of life cycle do you typically have on something like this? From, like, we have a concept to actually having it in your hands to what type of test time are we talking about?
Our customers usually look for at least 100,000 hours of mean time before failure. So that gives you an idea of how long the product needs to operate without failing. But as far as a life cycle goes, this product has been going for 6 or 7 years, and this board does a specific thing, and we add features and software, right? So again, it's more of a platform and less of something specific. So this board could be in service for 6+ years, but the processor module that adds all these extra features has been enhanced. Does that answer your question?
Yeah, I'm thinking more along the lines of from the time you get a concept to something in your hands to something that you can actually release to a customer.
Oh, I see. So we operate on a waterfall methodology, and based on the complexity of the product, it can really change. So it's pretty typical for us to be about on a 12 or an 18-month schedule where we've got an idea. So we've got an architecture group that dreams up the idea and brings it to customers, and they say, yeah, that's a terrible idea, we don't want that. Or they say, that's a fantastic idea, we'll buy a whole bunch of those. And then we start looking at how much it would cost to actually build something like that, and what are some of the real components, the expensive pieces that we'd have to put into place. And then, we can take that back to our customer and say, well, you can have it in 16 months. And they say, nope, we'll take it in 12. And then we try and do it in 12. But yeah, it's usually 12 to 18 months.
Any last questions for Ben? Okay, excellent. Thank you very much, Ben. That brings to a close our February session. March is coming up. It's already in Meetup. We'll do the formal announcement of it next week. But you're here, so you get to find out early. We are going to do something new next month as well. We're actually going to do a workshop, a 45-minute workshop on session-based test management. We've talked about it in previous sessions, and there's been a lot of requests to get some hands-on time with session-based test management. So we're going to do one full life cycle of session-based test management compressed into a lunch hour with pizza. And so that will be the third Wednesday in March coming up. It's already in Meetup. Formal annouement to come out next week. Thank you very much for coming out.